In 1985, a Boeing 747 broke apart in midair with 524 people on board. It remains the deadliest single aircraft crash in history, and it happened because of a repair mistake made 7 years earlier, one that was sitting in the maintenance records the entire time. The flight was Japan Airlines 123, a routine domestic hop from Tokyo to Osaka. 12 minutes into the climb, the back of the aircraft tore open. For the next 32 minutes, the pilots fought to control a plane that could no longer be controlled. It crashed into a mountain ridge. 520 people died. The cause was not a storm. It was not pilot error. It was a repair, done wrong, 7 years earlier, and never caught. To understand what went wrong, you need to understand one component: the aft pressure bulkhead. It sits at the rear of the passenger cabin, a curved metal wall roughly the size of a large garage door. Its job is to hold back the pressure differential between the sealed cabin and the thin air outside at cruising altitude. Every time the aircraft climbs, that bulkhead flexes outward under pressure. Every time it descends, it flexes back. On a short-haul domestic aircraft, this happens multiple times a day. The bulkhead is designed for this. It is engineered for tens of thousands of cycles, but only if it is built correctly. The aircraft that became Flight 123 was a Boeing 747 SR, the SR standing for short range, a variant built specifically for Japan's high-frequency domestic routes. It entered service with Japan Airlines in 1974. By 1978, it had accumulated thousands of flights. Then, on June 2, 1978, while landing at Osaka International Airport, the tail of the aircraft struck the runway. Verify confirm date. A tail strike is not automatically catastrophic. Aircraft are built to absorb ground incidents. The plane landed safely, the passengers disembarked, and the aircraft was taken out of service for inspection and repair. Boeing sent a team to assess the damage. What they found was significant. The tail strike had damaged the aft pressure bulkhead. It needed to be repaired before the aircraft could return to service. The approved repair method called for a single continuous splice plate, a reinforcing strip of metal fastened across the damaged area using 2 rows of rivets. This configuration was load-bearing. The 2 rows of rivets, working together, would restore the bulkhead's structural integrity to its original specification. Boeing's repair team did not follow that method. Instead of one continuous plate, they used 2 separate smaller plates. And instead of 2 rows of rivets holding the splice, they used 1. A single row of rivets, where 2 were required. The structural consequence of this deviation was significant. A single row of rivets carries less than half the fatigue resistance of a 2-row configuration across a pressurized joint. The repair was approved, the aircraft returned to service, and the records were filed. Nobody flagged the deviation at the time. Nobody compared the completed repair to the engineering drawings and noted the discrepancy. The plane flew again. And it kept flying. For 7 years. Between the 1978 repair and the August 1985 accident, the aircraft completed more than 12,000 pressurization cycles. Verify and confirm the cycle count from the JTSB report. Every single one of those cycles put load on that weakened splice. The physics here is not subtle. Metal under repeated cyclical stress develops cracks, invisible at first, growing incrementally with each cycle. Engineers call it fatigue. The term is accurate. The metal was being worn down with every flight, in a location that nobody had any reason to look at closely because nobody knew there was anything wrong with it. Japan Airlines conducted regular maintenance on the aircraft throughout this period. Inspections were performed, logbooks were kept, the tail section was examined. But the inspection protocols in place did not require the repair area to be opened up and inspected at the structural level. A surface inspection of the bulkhead showed nothing unusual because the fatigue was happening inside the joint, in the interface between the splice plate and the bulkhead skin. Without removing the splice plate, you could not see it. And nobody removed it because the records did not tell them there was a reason to. This is the central failure. Not a moment of deliberate negligence, not a manager who told an engineer to be quiet. The failure was a documentation and audit gap, a repair that deviated from specification and was never caught by any downstream check. The paper trail existed, the repair records existed, the Boeing engineering drawings existed, nobody compared them. On August 12, 1985, Japan Airlines Flight 123 pushed back from the gate at Haneda Airport in Tokyo at 6:04 p.m. It was carrying 509 passengers and 15 crew. The destination was Osaka, a flight of about an hour. The 747 took off at 6:12 p.m. The weather was clear. The aircraft climbed normally through its initial altitude assignments. At 6:24 p.m., approximately 12 minutes after takeoff, the aft pressure bulkhead failed. The failure was sudden and total. The weakened splice, after more than 12,000 cycles, gave way. The pressure difference between the cabin and the outside air, contained until that moment, released instantly into the rear of the fuselage. The explosive decompression destroyed the rear of the aircraft. The vertical stabilizer, the large tail fin that keeps the aircraft pointed forward, was torn away. It fell into the sea below. With it went the hydraulic lines, all 4 of them. On a 747, the hydraulic systems power the flight control surfaces, the rudder, the elevators, the ailerons. Without hydraulics, the pilots had none of these. Captain Masami Takahashi and his crew were now operating a 747 with thrust from 4 engines and almost no way to direct it. What followed has been studied in aviation training programs ever since. For 32 minutes, the crew used differential engine thrust to attempt to steer the aircraft. They managed to keep it airborne. They fought a phenomenon called phugoid oscillation, a slow repeating pitch cycle that, without control surfaces, the crew could only partially dampen. The aircraft climbed and descended, turned without being commanded to turn, and drifted northwest over the mountains of central Japan. At 6:56 p.m., Flight 123 struck the ridge of Osutaka Mountain in Gunma Prefecture, breaking apart on impact. Of the 524 people on board, 520 died. 4 passengers survived, found in the wreckage the following morning. Japan's Aircraft Accident Investigation Authority, now known as the Japan Transport Safety Board, led the investigation with NTSB participation. Within months, investigators had traced the structural failure back to the repaired bulkhead, and from there back to the 1978 Boeing repair. The metallurgical evidence from the recovered wreckage confirmed fatigue cracking originating at the splice joint. The crack pattern was consistent with the reduced fatigue life of a single-row rivet configuration. Boeing acknowledged that the repair had not been performed to the approved engineering specification. The investigation's findings were precise and damning. The improper repair had reduced the bulkhead's fatigue life significantly. The inspection regime in place at Japan Airlines had no procedure that would have detected the internal cracking without disassembling the repair. Neither Boeing nor Japan Airlines had a system for auditing completed repairs against original engineering drawings after the aircraft returned to service. The deviation from specification had been present in the records from 1978. Nobody had looked. The aftermath produced regulatory changes across the industry. Pressure bulkhead inspection intervals were reviewed. Repair documentation standards were tightened. The concept of repair audit, checking completed work against original engineering drawings at a later maintenance interval, gained traction in aviation oversight frameworks. Boeing reached a settlement with the families of victims. The amounts were not disclosed. No criminal charges were filed in Japan against Boeing personnel, though Japanese prosecutors investigated. The crew of Flight 123 are remembered in Japan as professionals, who did everything possible with an aircraft that had been made unflyable by a decision made on the ground 7 years before they ever climbed into its cockpit. Captain Takahashi's handling of the aircraft in those 32 minutes is considered one of the most sustained examples of airmanship under impossible conditions in the history of aviation. The paper trail for this disaster begins in a hangar in 1978. It runs through 7 years of maintenance logs, inspection records, and repair documentation. It ends on a mountain in Gunma Prefecture. Every step of it was traceable, in retrospect, from records that existed and were never connected. The failure was not that nobody saw it coming. The failure was that they did. If you want to keep following the warnings the world ignored, subscribe. Every disaster leaves a paper trail. We follow it.